Right, students? So have you noted this one? Everybody?
Yes, sir.
Okay. Right. So this thing I am just erasing from here because then I can't solve it. So for me, the question is when P is going to catch Q. Remaining all I am not going to see. Okay. But first thing, is P going to catch Q? Is that clarity there with you? Because P is going to move in this direction to catch Q. Q is going to move in this direction. R is going to move in this direction and S is going to move in this direction. Will they be able to catch each other?
No, sir.
No. Ishania, what do you say? Yes, Ishania. Tell me fast. Ishania, what happened to her? She said she has done this question. Ishania. She's silent. I don't know. Maybe network problem. Vishnu? Yes,
Sir,
Vishnu?
I haven't done this, sir.
You haven't done this. That's why you're safe, huh? So I cannot pull your leg, right? Good. Others, what about you?
Sir, they will not catch, sir.
They will not catch. That means you also have not done this question, right?
Sir, can we take hypotenuse VR, sir?
No, like first let's understand the question. Okay. Understanding is important. Then solving is very easy. We will solve it. Our method is there, no relative. We'll solve it immediately. There's no issues. Understand the question. Okay, Sayan, what about you? Have you done this? Yes, Sayan.
I don't remember, sir.
Don't remember. You also want to play safe, huh? Okay, fine. No issues. Let's see. Let's see what happens. Okay. Now, P wants to catch Q. That is the condition. Okay. So what is happening? P started from here in this direction because he's seeing the Q is here. He started in this direction. Okay. But what happened? Q also started. Q also started moving towards R. So when P reached here, let's say this point here, he saw Q again. He found Q is not here. He's here. So what happened? He changed the direction because P has to catch Q. Nobody is saying that P will run like this only. Question didn't say that. P is not going to run along this side. No. P has to catch Q. So what will happen is immediately P will change the direction. He will make the direction towards Q. Like this. Direction changed. Okay. Now Q also has to catch R. Q also saw that R is no more here. R is here. Q will also change the direction. Change the direction like this. Now what happened? Next instant P saw that Q is no more here. He is here. So he changed the direction again like this. Then Q again changed the direction because R is somewhere here now. Like this. Again, P again saw Q is not here. Q is here now. Change the direction. Right? Q again changed the direction. Became like this. So again P changed. Will they meet? Tell me.
Yes, sir. They'll meet, sir.
They will meet. It looks like they are meeting in fact. Okay. This is the next and this is this. They are going to meet. But where they are meeting? The center. Because R will come like this. And S will come like this. All four will meet. Where? At the center. This is the question. This is what question is asking us. Okay. So we understood that yes, they are going to meet. Where? At the center. All four particles will meet at center of this square. This is clear, no doubt about that. But question is asking when, at what time, how to find that. Okay. So for that thing, what do you require? I require only P and Q. I don't require anything else. Okay. So P and Q, let's see. This P, yes Q. Distance D. Okay, fine. Then what? I know that P starts in this direction with speed V. And Q starts in this direction with speed V. That's it. That's enough for us. Okay. What we have to do? Since P is going to meet Q or P is going to catch Q, I know that relative motion I'll use. I know. I have to use what? Relative motion. Fine. So velocity of P with respect to Q. Yes. So when you remember that, whenever I am going to take velocity of P with respect to Q, for me Q is at rest. Okay. And P will move with velocity of P with respect to Q. Right. That's what we have understood. Whenever I say velocity of A with respect to V, I'll say B is at rest. And A moves with relative velocity. Correct? Exactly same thing I'm going to do over here. Okay. So for me, P's velocity will be what? Velocity of P with respect to Q, and Q is at rest. So when Q is at rest, that means how much distance P has to move to catch Q? D. Only D. No doubt about that. Okay. How much distance P has to travel to meet Q? Only D. So displacement of P with respect to Q is D. Done. Now velocity of P with respect to Q. Okay. Now here question is, Q is at rest, we said. It's here. P is coming like this. Okay. So we have velocity of P with respect to Q. But which component of velocity I require to meet Q? Only horizontal. Do I require vertical component also? Not required. Only horizontal. Why I'm asking you this? Because when I'm writing VPQ, I have both components. Because it's VP minus VQ, right? This is what? VP minus VQ. See, if I'm going to write it in vectors, something like this. I'll write this as DI cap. And VP will become, VP means velocity of P. Velocity of P is V along x-axis. So this is VI cap. Minus VQ. VQ is what? Along J cap. That's why we say no, it's two-dimensional, relative motion in 2 dimensions. But XPQ is DI. That means along x-axis. So I require velocity also along x-axis. Okay, right? Any acceleration? There's no acceleration. Nobody is moving with acceleration. All are moving with the same speed, constant speed throughout. So there is no acceleration. So acceleration PQ is 0. Very good. So now it's very easy for me. What is there? Nothing. See now, XPQ, okay, equal to velocity PQ along x-axis. That means I cap, because this is I cap. Okay, XPQ, VPQ into T. X equal to ut plus half a t square, but a is 0. What to do? X equal to ut only. Okay, so this is D, this is V, and this is T. So T equal to D by V. That's all. Yes. Finished.